Hey everybody, so this is our final video for this chapter. This is another topic of trigonometry involving angle of elevation and angle of depression. So with these, we're going to have to draw our own pictures based on the description that's given to us and then use trigonometry to solve the problem. So the first thing is angle of elevation. Angle of elevation is found when looking up to an object. So if you can see in the picture over here, we have a person that's looking up with their line of sight. They're looking up at the top of a lighthouse. The angle of elevation is the angle that's created with the horizontal line from their eyesight to the top, and then the angle that's formed with the line of sight and that horizontal line. So that's called your angle of elevation. So the first question is kind of represented by this picture. Casey sights the top of an 84-foot tall lighthouse. So she has an angle of, or he has an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So I'm going to kind of redraw this picture, but when it comes to drawing pictures, really, we don't need much detail. What we're really trying to get is just a right triangle. So we have Casey's eyes are about there. We can just represent it by a dot. If you want to even put a C to represent Casey, that's fine too. All right, he's looking up to the top of the lighthouse. The top of the lighthouse, I'm going to represent with another point. The lighthouse is 84 foot tall. So I'm going to draw this vertical segment that's 84 feet tall. And then we have Casey is 6 feet tall. And then here I'll just put a line to represent the ground. And then we have the angle of elevation, which is made by a horizontal line, and then the line of sight, that's 84 degrees, is 58 degrees. All right, so there's our picture. Okay, so we're trying to figure out how far is Casey standing from the lighthouse. So that's going to be x, the horizontal distance. Okay, well, the first thing that we can do here is figure out, okay, we have our right triangle, which is right here. But the only problem is there's two unknown parts here. We actually don't know what this length is, but we do know that from here to here, this is 6 feet, because that's how tall Casey is. And then the entire thing is 84. So if we just do a quick 84 minus 6, that's going to leave us with 78. So now in our right triangle, we can figure out using trigonometry this missing length. So we're going to do our previous steps. We're going to start off by circling the acute angle, which is 58. We're going to label what we have. We have the opposite, so I'm going to put O, and we want the adjacent, so I'm going to put A. Now we think of SOHCAHTOA. Which of those involves an O and an A, an opposite and adjacent? And that would be tangent. TOA. So the T stands for tangent, so I'm going to start off by writing the tangent of, in parentheses we put the acute angle, which is 58 degrees, equals opposite over adjacent. So that's going to be 78 over x. Okay, so we're going to solve this one by cross multiplying. When we cross multiply, we get x times the tangent of 58 equals 78. Then we're going to divide both sides by the tangent of 58, and that's going to tell us what x is. So divide tangent of 58 by tangent of 58, and that's going to cancel. And then divide 78 by the tangent of 58, and that's going to give us our x value. So just one thing I want to remind you, when you are using any calculator, if you're using this calculator, you hit mode and then make sure that it's in degree mode. If you're using the Desmos calculator, you want to make sure, you take a look, you want to hit the word function. No, you want to actually just make sure that it's in degree mode. So right above the number 7, it should say DEG for degree. If it's not in degree mode, just make sure you click that and put it in the right mode. Okay, so we're going to type in 78 divided by the tangent of 58, and we get 48.73. They want the tenth, so 48.7. So x is 48.7 feet. All right, so that's how we use trigonometry and angle of elevation. All right, so let's do another one. So the next one's a little bit more simple. The angle of elevation from a kicker's foot on the football field to the top of the goalpost is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? So simple picture here. Here's the kicker's feet. I'm going to draw the ground, the distance from the kicker's foot to the goalpost. We know that that's 131 feet. They want to know how tall is the goalpost, so I'll put a vertical line representing the height of the goalpost. And we don't know what that is, so I'll put an X there. And then we do know that the top of the goalpost makes a 17-degree angle with the kicker's foot. So that would be that line, and that's 17 degrees. Okay, so there's our picture. So to solve this one, we're going to circle the acute angle, label the opposite is what we want, the adjacent is what we have. We have O and A again. O and A represent tangent, so we're going to do the tangent of 17 equals x over 131. Now we're going to cross multiply. X multiplies with this invisible 1 that's down here. X times 1 is x, so we get x is approximately, and then we multiply 131 times the tangent of 17. And we get 40.1. So the height of the goalpost is 40.1 feet. All right. The next question, Leah's mom is standing at the bottom of a slide at the playground waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees, and the slide has a vertical height of 9 feet, find the length of the slide. Okay, so I'll represent a dot for the bottom of the slide. We know that, draw the slide here. Here's the horizontal distance, and then here's the height of the slide. Okay, so the vertical height of the slide is 9 feet. The angle from the bottom of the slide to the top of the slide is 46 degrees. So that's the angle of elevation. And the question is, find the length of the slide. So that would be this distance right here, the hypotenuse. All right, so to do this one, I'm going to circle the angle. The one that we have is the opposite side. The one that we want is the hypotenuse. So if we do our SOHCAHTOA, opposite and hypotenuse, that goes with the S, sine. So it's going to be the sine of 46 equals 9 over x. So when we cross multiply, we get x times the sine of 46 equals 9. And then we would divide both sides by the sine of 46. And that would give us our value. So we're going to do 9 divided by the sine of 46. And we get 12.5. So the length of the slide is about 12.5 feet. Okay, and now our last angle of elevation question. A dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? So we have a dog on the ground. We have a cat up in a tree. I'll draw a vertical line to represent the height of the cat in the tree, and then I'll draw a horizontal line to represent the ground. And then to finish this off, the line of sight from the dog to the cat. And the horizontal and vertical line make that right angle. Okay, so a dog is standing 5 feet from the base of the tree, and the cat climbs 16 feet up into the tree. As you can see, my picture is definitely not drawn to scale, but the numbers are really what just matters here. Now they want to know what is the angle of elevation. So actually they want to know what is the measure of this angle right here. So now, whenever we're trying to find the angle measure that's missing, we're going to use inverse trigonometry. So the two sides they gave us were the side that's opposite and the adjacent. So we're going to use inverse tangent to find the measure of the angle. So we're going to do the inverse tangent of opposite over adjacent, so of 16 over 5. And that's going to give us the angle of elevation from the dog looking up at the cat. So I'm going to do the tangent inverse. So do second tangent inverse of 16 divided by 5. Now if you're using the Desmos calculator, the way that it's worded there, you have to click on the function, F-U-N-C button. And when you click on the function button, you'll end up seeing we have sine, cosine, tangent, and we also have sine inverse, cosine inverse, and tangent inverse. So you have to hit function and then tangent inverse, and then type in 16 divided by 5. Okay, now when you do that, you'll get 72.6, and we know that that's an angle of elevation, so it's a degree measure. So it'll be 72.6 degrees. All right, on to the back. Now we're going to talk about angle of depression. So when looking down to an object, the angle of depression is formed by an observer's line of sight and a horizontal line. The angle of depression is congruent to the angle of elevation because they are alternate interior angles. So in number 5, a lifeguard is sitting on a platform. So we're looking at this picture here. There's multiple ways of drawing these, kind of depends on how you see it. So I'm going to show you maybe a different way of drawing this picture. All right, so a lifeguard is sitting on a platform looking down at a swimmer in the water. So we know that we have a lifeguard up high, looking down, line of sight, at a swimmer in the water. If the lifeguard's line of sight is 8 feet, so that would be, this number is 8. And the angle of depression to the swimmer is 18 degrees. So the angle of depression is formed by the horizontal line from the lifeguard and the line of sight. So this angle right here, that angle is 18 degrees. The question is, how far away is the swimmer from the lifeguard? So that would be the horizontal distance. So if I was to flip this around a little bit, this would represent the distance from the lifeguard to the swimmer, but then the line that's parallel to it also represents the distance from the lifeguard to the swimmer. So we can look either way. So I'm going to mark it right here. This would be the distance from the lifeguard to the swimmer, the horizontal distance. So that'll be our x. Okay, so to solve this one, we're trying to figure out what x is. So I'm going to circle the angle. The side they give us, that's the hypotenuse. And then the side they want is the adjacent. So we have A and H. So with our SOHCAHTOA, A and H goes with C. So that'd be cosine. So it's going to be the cosine of 18 equals x over 8. Now to solve this question, we just cross multiply. X multiplies with 1, so we get x is approximately, and then we do cosine of 18 times 8, and that's just something we type in the calculator. and we get 7.6. So the distance from the lifeguard to the swimmer is 7.6 feet. All right, another example. Pilot in a helicopter spots a landing pad below. So we have a helicopter up in the sky, and it spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude or the height of the helicopter? So if you're in the helicopter looking down at the landing pad, there's your line of sight. The horizontal distance from the helicopter to the pad is 1,200 feet. The angle of depression is 73 degrees. What is the altitude of the helicopter? That's the vertical distance. So that's going to be our x. So in this question, circle the angle, label. The side that's given to us is the adjacent side. The side that we want is the opposite side. O and A, that's TOA, so it's going to be the tangent of 73 equals x over 1,200. Now we're going to cross multiply. X multiplies with that invisible 1, so we get x is approximately, and then multiply 1,200 times the tangent of 73. And you should get 3,925.0. And that's feet. So that's how far the helicopter is from the landing pad. All right, number 7. Building A is 480 feet tall, and building B is 654 feet tall. So this is a different type of question. So building A, 480 feet tall. Building B is taller, 654 feet tall. If the angle of depression from the top of building A to angle B is 42 degrees, how far are the buildings apart? Okay, so we're trying to figure out how far is it between the two buildings. So that's the horizontal line. And then the angle of depression from angle B to angle A is actually formed by the horizontal line from the top of angle or of building B to the line of sight. So that would actually be right here. Now if we look up at the top, angle of elevation and angle of depression are alternate interior angles. So that means if the angle of depression from angle B to angle A is 42 degrees, then the angle of elevation from angle A to angle B is also going to be 42 degrees. So here's our triangle that we're looking at. So this one's a little bit different because, well, again, we're missing two things. They want to know what is the distance. So that would be that horizontal distance here. We also need to know this. They don't directly give it to us, but we do know the entire length is 554. And then from just here to here, that would be 480. So to figure out this missing part, we're going to do 654 minus 480. And we get 174. So building B is 174 feet taller. So we're going to use our trigonometry now. Circle the angle. The given is the opposite. The one that we want is the adjacent. O and A, that's going to be tangent. So we're going to do the tangent of 42 equals 174 over x. Cross multiply, we would get x tangent of 42 equals 174, and then we would divide both sides by tangent of 42. So 174 divided by the tangent of 42. That gives us 193.2. And that's in feet. So the buildings are 193.2 feet apart. All right, our last question. Zach is standing at the top of a lookout tower and spots a water fountain below. If the lookout tower is 75 feet tall and the angle of depression is 28 degrees, what's the horizontal distance between Zach and the water fountain? So Zach's up high at the top of a lookout tower. The water fountain is below. The lookout tower is 75 foot tall. And the angle of depression is 28 degrees. So again, the angle of depression is formed by the horizontal line from Zach and then the line of sight to the water fountain. So that would be 28 degrees. Now what we want to remember is that if the angle of depression from Zach to the water fountain is 28 degrees, then the angle of elevation from the water fountain to Zach is also 28 degrees because they're alternate interior angles. What is the horizontal distance between Zach and the fountain? So the horizontal line, that's going to be our x. So we have our right triangle here. Circle the 28. The side they gave us is the opposite. The side that they want is the adjacent. O and A, that's tangent. So we're going to do the tangent of 28 equals 75 over x. Cross multiply. We would do x times the tangent of 28 equals 75, and then divide both sides by the tangent of 28. So we do 75 divided by the tangent of 28. And we get 141.1. And that's in feet. So that's how far Zach's horizontal distance is from the water fountain. All right, so that's all we have for today. If you have any questions, make sure you let us know. Have a good day.